Hello ladies and gentlemen, welcome to part 2.3 of our test-driven development techniques video tutorial. My name is Vasily, I am a professional software engineer. In the previous two videos of this series, we started the demonstration of Uncle Bob's test-driven development techniques, which is based on just three simple rules. Rule number 1. You are not allowed to write any production code unless it is to make a failing unit test pass. Rule number 2. You are not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are failures. And the last rule is that you are not allowed to write any more production code than is sufficient to pass the one failing unit test. Just to remind you that we were working on a driving lessons registration management system, and we wanted to implement instructor schedule class that will take care of the following business constraints. Instructors work between 8 a.m. and 4 p.m. Instructors can teach more than one student at a time. Instructors do not work on weekends. And instructors have additional vacation days. In the previous parts of this tutorial, we already implemented most of the required functionality. We shall complete it now and refactor our code and our tests for maintainability. So let's get to work. It is time to make our assumption about the day of the lesson being the same one explicit. So schedule lesson, start date and end date different, exception thrown. Expected, let's say it's still an illegal argument. Cool. So what we'd like to test is that when the lesson with start date, date time minus days 1 and with end date. Okay, so when this lesson that starts one day before it ends is being passed to our system under test, we expect it to throw an exception. Test it. And of course this method fails because the exception is not being thrown right now. So we go to our system under test and add another precondition check that if lesson get start date time to local date equals not equals please to lesson get end date time to local date, we again throw illegal argument exception. We run the tests. All tests pass. Great. So we will refactor all this now. However, before we begin, I would just like to commit, or maybe not commit, but at least stage the current state, so that during refactoring, if something goes wrong, we can always get back to the known good state. First of all, refactor of the production code. This is a single method which we'll call assert 0 minutes and seconds. Nice. And this one is additional method which we will call assert start and end dates the same. And this condition is also a good candidate to be extracted to a method which we'll call is lesson scheduled outside of instructors work hours. Well, pretty long name, however descriptive, so I'll keep it like that. And this condition should also be extracted to a method is lesson scheduled for instructor vacation day. Great. And now I see that we can even combine this. So it will be like that. This one we can erase. Let's ensure that all the unit tests still pass. And now it is time to do something with this ugly code. Alright, so we extract this to a method which we called doOverlap, right? So if the lessons overlap, we return false. That will be correct. Let's rerun the tests just to ensure that everything works. And now the thing is that I believe that this part is not really necessary. Let's run the tests. Oh, nope, it is still necessary. Why is that? Something is wrong. So when we attempt to schedule the same lesson twice, the test expects the code to reject the second attempt. However, in practice, it is not being rejected. Obviously, there is some bug in our production code, and I guess it is somehow related to age conditions. You know, when one lesson starts when other lessons ends, or vice versa. These edge conditions are always tricky, and we should always test for them. The fact that this test failed once I removed seemingly unrelated statement really means that I didn't have a good test suite to start with, so I did not test for all the conditions, and just by accident I found out that I still have some bugs in the design. When we refactor the code and tests fail, we basically have two options. Option number one is to revert the changes, basically restore the previous good known state of the code. Option number two is to debug the failure in some other way. In this case, because I know that this failure indicates some gap in my test suite, I would like to start with restoring the previous good known state, rerunning the tests, and then adding some additional test cases in order to close this gap in my test suite. So currently we have just this test. It ensures that the design rejects a lesson if it is exactly as one of the already scheduled ones. We would like to make this test more targeting. For example, we can attempt to schedule lesson with same start hour, start daytime. So lesson 1 will be a valid lesson with start time instructor +1, for example, and end time +4, for example. And the second one will be exactly the same start time, however the end time will be different. So the second lesson is contained within the first lesson and they have the same start time. So we attempt to schedule lesson 1 and that will succeed, and then we attempt to schedule lesson 2 and we expect it to be rejected. We run the tests. Right, this new test failed. Very good. It means that we reproduce the issue and we can actually understand why our design failed and fix it. So I will start with just commenting out the existing logic and writing a completely new implementation which will be much cleaner and more understandable. What needs to happen in order for those lessons to overlap? Well, first of all is before lesson scheduled lesson. So the new lesson should not be before, strictly before the scheduled lesson, and it should not be after. So if the new lesson is not strictly before the scheduled lesson and it is not strictly after the scheduled lesson, then somewhere these lessons overlap. Let's write the implementation of is before. Okay, what does it mean for the lesson to be before? It means that lesson gets start time before scheduled lesson start time, and lesson end time before scheduled lesson start time, or lesson end time exactly as the scheduled lesson start time. So this additional condition will take care of this edge case, boundary case, that we failed to handle properly the last time. And now to the implementation of is after. Alright, so we need to ensure that lesson, okay, so lesson start time is, let's start with equals, exactly as scheduled lesson end time, right? Or lesson start time after scheduled lesson end time, and lesson end time after scheduled lesson end time. If no mistakes were made so far, we should rerun the test and see all of them pass. Yoo-hoo! All the tests passed. So we can really delete this ugly implementation and we will stay with this pretty elegant one. And since we reached another good state of the code, let's commit it. Let's stage the changes and continue refactoring it. So let's see if there is anything left to refactor. Less space, please. Maybe add another space here. Everything seems kosher to me, so let's do the same with the test code. Remember, our test code is as important or maybe even more important than our production code. So make sure that the tests look good, everything is readable. Okay, see, these are the artifacts from, we would like to have it valid lesson with start date time and with end date time, and we can erase this one. Rerun the tests. Alright, good. Here we would like to do the same. Lesson with start, with end, and erase this one. Test, please. Also good, and these are good ones. So just less space, please. Why do I put so many spaces in between them? Never mind. It's just several seconds of work. Even though it looks like a wasted effort, it is not. It is super important to make your test classes readable. And it looks like we are done here, so we can finally go and do this. Commit instructor calendar schedule, instructor schedule implementation completed. Yay, completed! Some of you might be surprised by the amount of test cases that we wrote. Maybe you even think that it is not worth it because without the test, you could write the same class in 10 minutes and call it a day. That will be a very unfortunate takeaway from this tutorial. Therefore, let's discuss this in details. First of all, the code that involves time manipulations is known to be among the most difficult to get right. Bugs related to dates and times are very hard to spot in the code and are super tricky to catch in manual testing. When these bugs make it into production code, they don't usually cause the system to crash right away, but frustrate the users for a long time or allow for silent corruption of business data. There is simply no such thing, in my opinion, as too much testing for daytime related code. You saw it yourself that even using test-driven development, I still ended up having some bugs in the production code. And it was a mix of luck and experience that allowed me to understand that there are some gaps in my test suite and fill them and then fix the design. If I would need to write this class without using test-driven development, I would probably end with many bugs inside my production code. And I would find these bugs only much further down the road, and the cost of finding them and fixing them and then fixing the issues that they caused will be astronomically high. Sure, if your name is John Skid, then go ahead and just write the code. The universe will adjust in order to comply with your specification. The rest of us, well, we better write tests for our code, especially when dealing with datetime classes. Even now, after writing 19 test cases for this one single method, I am not completely sure that there are no edge cases that I missed. Probably I can sit another half an hour to hour after finishing this tutorial and find additional 5 to 10 edge cases that I did not cover. Therefore, yes, it is very well worth the investment to unit test your code, and the best way to do that is using test-driven development techniques. Back to Uncle Bob's test-driven development technique. I hope that the 3 rules are clear to you now. We start by writing tests, and we write tests until one of them fails. Then we add production code in order to fix the failure. After that, we write some more tests until one of them fails again. This technique puts us in a loop that ultimately ends when there are no more tests to add. At that point, the implementation of a method or an entire class is complete and should be refactored for maintainability. The advantages of Uncle Bob's technique is that at each instant of time we know that all previously written tests pass. It makes a debug of failing tests and writing production code very easy. You might have noticed that I put almost no effort into the design. I just wrote some lines of code that made the test pass. It was very easy. In addition, when using Uncle Bob's technique, since we do not write any production code without writing failing unit test first, we basically ensure that all the production code is covered with tests. Last but not least is that this technique is much more dynamic and fun than writing all the tests up front. However, in my opinion, there is one small disadvantage to this technique. You might have noticed that when using this technique, I constantly switched between abstraction levels. I thought about the test case, and then I dived into the source code, wrote the implementation of the test, and then wrote the production code and made sure that everything passes. And then I went back up to the higher abstraction level and had to think about the next test case. This context switch between different abstraction levels is very hard for me personally. Therefore, I use slightly different test-driven development technique that I will show you in the next tutorial. With that, I would like to thank you for watching this video. If you found this tutorial useful, please do not forget to like it and subscribe to our channel. See you next time. Goodbye.